Right. Welcome again. Today, I want to talk about practical development practices. So, Xiaoshong made a fantastic presentation on using the Go Standard Library to manipulate images. I recently, well, not recently, I recently started a year ago with Xendit, and I come across many less experienced developers, put it that way. So, I always advise them before you write any code, write the requirements. And with regard to requirements, I have grown quite attached to Cucumber and Gherkin. Well, Gherkin is the implementation of the specification language for Cucumber, and it looks like this. So today I'll go from beginning to end for a very simple project. And that very simple project is I want to maintain a comfortable temperature, otherwise known as a thermostat. And as a home resident, this is important. It specifies the context. As a home resident, what do I want to do? I want to have a comfortable temperature that is neither too hot nor too cold. Goldilocks bear. All right. So when it is too hot, I want to cool down. Given a measuring device, otherwise known as a thermometer, when the thermometer is above a certain threshold, I should see certain cooling effects. Maybe the air conditioner turns on and vice versa. So the first thing to do before writing any code is to write down your requirements. And this is very important. And Cucumber is a nice language to write down your requirements, because if you do it properly, you can test this. Cucumber comes with testing packages, and there's even a Go plugin if you like for Cucumber. Right. So, like any developer, I'm eager to jump into writing code. And my first draft may look like this. So, this is my main package in Go. I use the format package. Here's my main program. For the temperature from 0 Celsius to 100 Celsius, I go through. If it's less than this threshold, it's too cold. If it's greater than that threshold, it's too hot. Otherwise, it's just right. And even with this code, it's nasty. Don't do this, by the way. But even with this code, there are some implicit Go niceties and Go conventions that we can follow. Notice the early returns, right? If it's less than this threshold, return early. Well, it doesn't return. In this case, it's a for loop. It continues on with the loop. It short circuits the loop and goes round again. So Go code always looks a certain way. It's never too deeply indented. If your Go code is too deeply indented, it's bad Go code. So this is how better Go code should look like. And it runs. Well, let's see. Just for the fun of it. Where am I? Yeah. It runs. Control B. If it's below, it's too cold. If it's above, it's too hot. In between, it's just right. All right. Get back to the presentation. So that's don't write your code that way. That's nasty. No good. So object-oriented languages deal with identifying objects. So Go is not strictly an object-oriented language, but it's still important to think in terms of what are the things, objects, that are important in your problem domain, in your code. In this case, we need something that senses, and we need something that turns on the air conditioner or the heater, actuator. And if you had paid attention to Xiaoshong's code, it makes use of active verbs, things like sense and things like actuate. he did not use a term like sensor or actuator. Instead, he used Xiaosheng used verbs, and which is what I'm using now, sense and actuate. So I refactored my code, and this code actually for non-Go readers is actually a very pretty interesting code by itself. There's this strange thing called temp, which has something to do with a actually it's channel of integers. So sense somehow connects to this channel, and actuate also somehow connects to this channel. And there's this strange construct here called select, open brace, close brace, which is effectively an infinite loop, but it doesn't consume any resources. It's a wait forever. Why is that? Well, here is one of my favorite features of Go. Sense literally is like its own object, its own Go routine, as is actuate. So let's look at sense and actuate in greater detail. Here is the sense Go routine. It takes a variable temp, and it's of type channel. But look at this arrow, right? It always points to the left, but this stuff is sense pushes into chan. Think of it that way, all right? And this construct over here, go func, open brace and close brace, open close brackets. This is boilerplate code, by the way, but that's a lambda in other languages, or an anonymous function. So that's an anonymous function. Inside this anonymous function is a forever loop, things that run forever, services run forever. They should not ever stop. And I tell my less experienced developers, formatting is important. So I put blank lines here to highlight the really important part of my code. And all it does is, for integers starting from 0 to 100, push that integer into the temp channel. That's all it does. Push an integer into the temp channel and sleep for 90 milliseconds. Why 90 milliseconds? I didn't want to use the word 100 again. Okay, so the lesson here is quite a lot actually. There's this thing called a Go routine. There is this thing called a Go routine that can run forever independently. And there is a communication channel like this, where you can just push some values into that channel. Right now, the value I'm pushing into that channel is an int, but it could be a struct, it could be a pointer, it could be anything, any valid Go data type. And the Actuate Go routine, it's more or less the same, but now this channel is something that you pull out of the channel, right? Same boilerplate code here, same forever loop here, but now, look, I have a channel and I pull something out of it. It always points to the left because the right arrow is a point, literally a pointer. This one always points to the left. And when you've pulled it out, you assign it to this variable t. And if t is less than 25, print to call. If t is greater, this is the code you've seen before, all right? Otherwise, just write. Let's see whether draft number 2 runs, just for the fun of it. It should, but now with a 90 millisecond delay. Heating. That's right. Cooling. All right, it runs. Fine. Is this good code? I don't know. Where are my tests? I always tell less experienced developers, refactor, test, document. Why refactor first? Because mere mortal developers like me just want to write code first. So we plunge into writing code without writing tests. Bad boy. But what to do? I've written my code. So I need to refactor, make it nice. But I also want to write my test to make sure that my code runs properly. So let's still write the test. This is horrible code. Don't do it, but I accept it. Why? Because it's short, right? This is actually boilerplate code, typical boilerplate code for table-driven tests in Go. Something, again, I wouldn't say unique to Go. You can do it in other languages as well, but Go encourages this, put it this way. The test code may not look very readable because of all this gobbledygook here, but look, the test struct, the test data is very readable, right? If input is 24, output is -1. If it's 25, it's just right, output is 0, etc. This now is so readable, right? And that's acceptable test code for Go. So now I have written my test, and let's write the function. Actuate function, all right? Actuate t int. I have a problem now. It's supposed to accept a channel, right? But now it's accepting an int. All right. Yeah, because it's int over here. All right. Okay. This code works. I run the test. It's fine. And my magic numbers are now gone. My magic numbers are now replaced by constants, right? Too low is 25, too high is 30. So now at any time, if I want to change my thresholds, they're all in one place. That's a good way to write code. Good, right? And I still have my early returns here. Return -1, return 0, return 1, return 0. Good. So before I talk further, int. Int is not a good data type. Go can do so much better, all right? So let's alias temperature to int. Let's create a new data type in Go. That's how you do it. And let's make temperature an int. We can make it a float 64 or complex number if you like. I don't know why you make a temperature complex, but int or float is great. And here are two ways of creating a typed constant. I love Go. Go and int may not be an int could be a temperature, and a temperature and int is different. I'll show you in a while. So here are two ways of specifying typed constants. Low temperature is of type temperature and is assigned to 25. High temperature is a temperature which is cast from an integer. Two different ways of doing it. Function ptemp, short for print temperature, right? I take the temperature and I print it. And here's my main function. What do you think? Take a look at this program. I've been talking a lot, but you can read. Will it run? I love Go because I can run my presentation. Let's see. Ta-da! Run. Oops. What did it say? Program Go 21, I should put program numbers. Cannot use T, which is type integer, as type temperature. Go is that type specific. The type safety in Go is phenomenal. So an int is not, an int, I repeat, is not a temperature. Wow. Good. And that's a nice trick. But let's talk a bit more. Enumerations used in all languages. Enumerations are things like, what's your size? Small, medium, large? Go has enumerations as well, except that they're known as constants. So this particular construct here says small is a type size, which is actually alias to int, but a size is different from an int. Remember, temperature int. And it's assigned the value of 0. Iota means start counting from 0. So therefore, small is 0, medium is 1, and large is 2, but they are of type size, not of type integer. And if I run this right now, you can look at the main program. What do you think you will see? But before I run this program, this construct over here, %s, says express size, SZ, short for size, as a string. Let's run it. My size is, I don't understand this to be a string, but it happens to be the value 1 and is of type main.size. How do we make it properly a string? Thankfully, in the Go tools environment, golang.org, Go tools, there's this very helpful command named stringer. And we have this comment looking like thing. It's called Go generate. It's not really a command. It's more like a directive. It says, when you run Go generate, run stringer with these parameters. So you can install it that way. But what I will do is I'll run this code. I already installed stringer, so I'll run this code. Good. Right? So I've Go generated. When I run, if I just run main.go, see there are 2 Go routines here, I get exactly the same disappointing output. If I run all my Go functions, my size is medium. Let's do something nasty. Size.go is gone. Size, not size.go, size_string.go is back. If you type that, don't look at it, it's generated code. Looks nasty. But it's auto-generated for you. Right, back to the presentation. I really love this feature of Go enumerations. You get nice integer style Go enumerations, and you get string interpretations for free with this tool. It's called Stringer. Use it. It's good. Now, that was the short detour. Let's go back to the main programming. Back to bad practices. I didn't use temperature here. I use int. So this is where we left off. I won't go over it again, but this is a good starting point to talk about what actuates the actuate function, right? Now, here is where I tell my less experienced developers, when do you use verbs like actuate, and when do you use nouns, names like actuator? This may seem trivial to you. It's not. It's not. It makes your code much more understandable. I'll explain why in just a while. But for now, suffice to say, this actuator function encapsulates a Go routine that actuates something, right? And a display is just a normal function that prints out stuff. And sensor is a thing, an object that senses things. And sense is just this very simple routine, right? The sensor takes that channel and passes that channel into sense, and this code you have seen before. Right. Now, how does the main program look like? Draft number 3, after refactoring after rewriting tests. I still have my temperature sensor, which I created, but now I seem to be breaking the rules. Main function, I'm using nouns and not verbs. Why is Sewing going on like this? Why am I using nouns? Well, think about the main program as a company, an organization structure. That's how I write big programs. The main program is the structure which gives you the org chart. And in the org chart, you have a sensor department and an actuator department. And the communication channel is temp for temperature, right? So in my view, organizing large software systems is much like organizing a company or organizing a team. And every team or every department has a name: engineering department, sales department, sensor department, actuator department. And within each department or within each team, they do stuff. That's where the verbs come in. So let's run this. Okay. CD, go back up. It's good. All right, let's do that. Let's pass. It should. All it does, test actuate. And you saw test actuate before. That's test actuate, right? Better still work. It does. Heating, just right. Cooling. It works. So now we have refactored our code. We have tested our code. We have adjusted the naming so that when we read the code, it makes more sense, right? At least for me, right? How do we document our code? It's a challenging problem. Software, as you can read here, have things that change frequently and things that change less frequently. So that things that hold true for a long time, things that are almost always going to be true forever, I would like to document them in the README, in the repositories README. And how about things that change frequently? Code that is frequently updated. I don't like to put those in README. Instead, I want to put them into a code walkthrough, which I will talk about right after I show you my README. So things that don't change frequently is my title: Developing Software, Refactor, blah, blah, with Go. And it teaches software developers good software engineering practices. And it starts by all this. You can read for yourself. And these things don't ever change. They are very stable. So I put them in my README. So what is the code walkthrough? Well, I've created another file called developingsoftware.article. Here it is. It's a link. I can click on this link. Boom. Let me zoom in a little bit. Yeah, that's just right. Maybe another step. All right. Maintaining a comfortable temperature. I start by saying these are my requirements. Now, at this point in time, you are saying, Xiu Yin, why are you so stupid? You already have a requirements file. I saw it earlier. Why did you type all this in again? I did not. Let me show you. I use Vim. This is the source code for the article. Let me flip back to the slides. Requirements, I see all these things. Requirements, that's my header. Hey, it looks like Markdown. Yeah, it is Markdown. .code maintain conf feature. This points to the actual feature, and in the rendering, it got expanded. My main function is this. Don't tell me this is also linked in code. Of course it is. Main function is this. I type in this to show that it's in command draft 3 main goal. This is the code directive again. start displaying from the main function and end displaying when you have the close brace. Let's see. Start displaying at the main function, end displaying at the close brace. What does this do? It means if I change my source code, this documentation is automatically updated. Not only that, this documentation puts together what sensor does in the same page, what actuator does in the same page. I don't have to use GoDoc and bounce around different links. It's all in one article. It's all in one code walkthrough. I can read it like I read a book, but this is a self-updating book with a built-in table of contents. I can click on it and it goes to my main function. And that is how I like to document stuff that changes frequently. Right. So let's get back to my slides. So that's my code walkthrough. This code is available on GitHub. This presentation itself is code. Let me show you. Developing software slide. That's the source code for my presentation. That's the source code. It links to all those code snippets, right? And it renders like this. And that basically is my crash course in software development. My name is Xiu Yin. I work for Xendit, and Xendit is hiring. Contact me or go to the jobs page on Xendit. Should you like to apply for a job and work with me. Thank you.
Whoever's watching this on YouTube, you can see the replay and contact Srin or Sao Shong, right, for further questions and feedback. Right?